I told you, I don't care how many of them carfangled net subs you've got. I need my 15 cameras per pet store. By the time we're done here, we will learn how to break Class C networks into multiple sub networks. That'd be net subs based on specific host requirements. That was my best effort to be a giant pet store owner talking tech of some sort. Anyhow, we're changing the whole story when it comes to subnetting. So in the previous skill, we talked about subnetting as it relates to network requirements. That is, somebody comes up and says, I need 10 networks, or I need to break this into 50 different subnets, something like that. Now we're going to change it to where my microphone's falling down. There we go. Now we're going to change it to where we can actually, I completely lost. Hang on. We are going to do subnetting based on hosts per network, which is actually a little bit more common than the number of networks. We know how many devices we're going to need at each one of these locations, approximately, or at least a maximum number of devices that we want to provision for. That's how we're going to design our subnets at this point. A moment of homage to Sonic the Hedgehog, which inspired Petropolis, which is now expanding once again, but changing the story, as our dear business owner had said, to take 192.168.5.0/24, this is our network, and break it into subnets that handle 25 hosts per network. I know our eclectic business owner was saying, I need my 15 cameras per network, but the thing is, when you're thinking about cameras, which I can't write and talk at the same time. When you're thinking about cameras, you're not thinking about the wireless access point, for instance, to handle those cameras, or the router or the switch that connects to the router that the cameras can. I mean, there's a lot more devices than just those 15 cameras. So we're going to provision for 25 hosts per network for each one of the stores in the region. So the way this has changed is that we're interested in subnetting. It's still subnetting. We're taking one network, which is 192.168.5, right? And we're breaking it into more networks, but we're not as concerned with how many networks we get as much as we're concerned that we get our 25 devices per network. That network, each one of them has to allocate for 25 devices on each one of those networks, right? So here's how you do it. 3 steps. Now I know you're like, this is the same as what it was when we had this skill before. No. It's actually different. It's a subtle difference. Do you see it? Look closely. What's different? Right there. So about the only thing that changes from the previous way of subnetting is we're focusing on the number of hosts and using that number to binary. Now, there's going to be a subtle shift right after that. So that's why I've created a whole new skill on this, is because, again, you need to practice or else it can get confusing. So let's lay our binary chart in front of you. 128, 64, 32, 16, 8, 4, 2, 1. We have, 25 hosts per network. And so I'm looking here, I'm going, bam, right there. If you want to know 25 in all binary, the whole number is that's 25. But we still only care that it takes 5 bits. So to get 25 hosts, we need 5 bits. And this is where that subtle shift is going to come in. Let me just write our original subnet back up here, 192.168.5.0/24, right? 25 hosts per network. We know it takes 5 bits to get the number 25, so it's a Class C by default. We're starting with a Class C example. And let me write all this up. Okay, let me explain the shift. Up till now, we've been focusing on saying, I need 25 networks. That was the previous skill, was how do you break subnets down based on network requirements? So I was saying 25 networks, we would say we need 5 more network bits. But whoa, we're changing the story right now. Instead of saying I need more network bits, we're saying I need at least that many host bits. Thus, save the hosts. Where that came from, by the way, is I've been teaching for 1998. What would that be? 21 years? Wow. So back when I was teaching subnetting in classroom environments, I was developing this method, and one of my students was like, I don't know, how do I remember between the networks and the hosts? And someone just said, it's like the whales. That was when whales were a big thing. I don't know what happened to the whales since then, but it was like, save the whales. And someone was like, save the hosts. And you're thinking, what does that have to do with anything? Let me show you. Instead of focusing on adding more network bits, I'm focusing on saving the host bits. 5 of them, to be specific. So the form of networking where we're saying, I need more networks, and adding it that way, I'm not doing right now. I'm saying, I need to save the hosts, at least 5 of them, because I cannot get the number 25 with any less than 5. The rest of them can flip over to the dark side, the network bits, because we're still doing subnetting, right? We're still breaking one network into multiple networks. We're just saying, instead of focusing so much on how many networks do we get, I'm going to say, give me as many networks as I can, as long as I can get at least 25 hosts per network, right? That's it. Ta-da! That's the big difference between this and the previous flavor of subnetting. This now becomes a /27, or if you're a decimal kind of person, 255.255, and let's see, 128, 64, 32. That'd be 224, right? The lowest network bit converted back to a decimal becomes our increment, which is 128, 64, 32, 32. So we use that to generate our network ranges. Now, just a little side note, if that number happens to be less than the number of hosts per network, you've probably got an issue. So we'll say 192.168.5.0 because that's what we were given. That's where this whole thing began. And we'll just start adding 32. 192.168.5.32. Do you see why I said there may be an issue? 5.64, 5.96, and down we go, right? Fill in the end ranges. This goes through 192.168.5.31 through 63 through 95. And you get, I'm just not writing all that, right? Down we go. These are now the networks that we can allocate to all these individual stores. And we know that we get at least 25 IP addresses. As a matter of fact, it's pretty easy to do the math just by looking at it. We get 32 minus 2. Because you can't use the first and the last, right? And then if you just look at this, 1 through 30, there's our 30 IP addresses that we get on each one. So we've achieved our goal of getting those 25 IP addresses. Slight and subtle shift, but one worth practicing. We're now going to do a video for Class B and Class A because I want you to see them and get used to that shift. Again, subnetting is still new, so I want to make sure it's solid before we go on and just assume all of it is going well. For now, you've seen how to break Class C networks into multiple subnetworks based on specific host requirements. I hope this has been informative for you, and I'd like to thank you for viewing.